Hi everyone, my name is Tung. Today we will talk about activity 1 and activity 2. So, as part of our professional engineering report, I will review the first two activities focusing on manufacturing during mathematics. Activity 1, dimensional analysis, kinematics. In activity 1, I apply two dimensional analysis to prove the formula for global ring mirroring and the ring is dimensional. I also, this is my activity 1. Here. I also integrate our workshop medical lifting system using a 0.8 meter room and my specific design time of a second. I calculate the linear and angular velocity requirements for cell. Yeah. In activity 2, arithmetic and geometric professional thing. In activity 2, I use arithmetic to determine the total progression cost of 25 cover drills setting at 50 with the physical insert of per unit. Okay. In activity 2, given data, so wait, here the data. Xong rồi Tùng ơi, thằng này. It's
Hello everyone, I'm Pham. I'm studying at ST09101. In this presentation, I will explain section 1.3 engineering application of mathematical functions. The section contains 4 engineering problems that are solved using the different mathematical functions for each problem. I will explain the engineering scenario, the calculation steps, and final result. Let's begin with part A. Part A is about the exponential function. The engineering scenario requires an inductive electrical circuit in an arithmetic conventional system. The objective is to determine how long current increases from 1 ampere to 2 amperes. Step 1. The current is multiplied by the equation. I apply 2.5 multiplied by 1 minus e to the power of negative 80. Step 2. I substitute I multiply 1 into the equation. Then I grant the equation and apply the natural logarithm to drop to T1, and the result approximately 0.064 seconds. Next, I substitute I questions into the same question. Using the same method, I obtain T2, which is approximately 0.201 seconds. And finally, I substitute the two value. The time required for current to increase from 1 ampere to 2 ampere is approximately 0.40 seconds. Part B, trigonometric functions scenario. This problem analyzes the displacement of an aluminum sheet at tone. The equilibrium process occurs when the displacement is equals to 0. There are two different processes. Process 1. First, I set the equilibrium condition by substituting y equals 0 into the equation. Step 2. Then I use inverse Gaussian function to determine the first position solution with 41 or 41 degrees. Step 4. Finally, because Gaussian is positive in the first and fourth quadrants, the second positive position is 318.59 degrees. And result, therefore, the first two positive equilibrium positions are 41.41 degrees and 318.59 degrees. Next, process 2. Step 1. First, I substitute y equals 0 into the second equation. Step 2. Then I introduce the substitution constellation is transforming the equation into the quadratic equation. And step 3. Next, I solve the quadratic equation and obtain two values of cotangent x. Step 4. Finally, I convert the cotangent value into the integral and determine the first two zero position solution. And result. Therefore, the first two positive value of x are 40.04 degrees and 146.31 degrees. Then part C. Hyperbolic functions scenario. During this inspections of high voltage transmission line, the cable profile is modeled using an hyperbolic cost function. The objectives are to determine the value of y when it's equals 35 and the equals when it's went by equals 62.35. Part 1. Step 1. First, I substitute is equal 35 into the given equation. And part 2. Next, I apply the exponential from the hyperbolic cosine functions. And step 3. Then I calculate the value of x. And result, therefore, the value of y is 64.98. Part 2. Step 1. First, I substitute y equals 60.35 into the equation. Step 2. Next, I apply the exponential form of the hyperbolic cosine functions. Step 3. Then I from the quadratic equation by introducing a new variable. And step 4. Finally, I solve the quadratic equation and apply natural logarithm to determine the positive engineering solution is symmetric. And result, therefore, the value of x is 31.05. Finally, part B. Logarithmic functions. The scenario in the problem. Three compressors work together in a pneumatic control system. The objective is to calculate the total output pressures. Step 1. First, I identify the given logarithmic presence and the assigned value of this one jet. And step 2. Then I substitute the assigned value to the trigonometric expression. And step 3. Then I apply the logarithmic law to the combine the three expressions to decide a single logarithmic. Step 4. Finally, I calculate the total output pressure. And result, the total output pressure of compressors is 1.046. Calculation. To conclude, I have present for engineering application to mathematical functions, exponential functions, requires current flow in electrical processes, trigonometric functions require equilibrium functions, hyperbolic functions model trans couple price, logarithmic function simplify expression calculation it and thank you for your attention.
Hello everyone, my name is Pham and Tung. I'm from class ST09101. Today I would like to present about activity 4. First, I would like to begin with A. I require me determine the mode and the median, the mean, and the standard deviation. I apply the heuristic statistic to the inspection time data, and I found that the dataset is number because no value appear more than 1. The mean is 135.5 seconds, and the mean is 136.33 36.72 seconds, and the standard deviation is 36.78 seconds. The second I would like to listen about is B require find the probability of finding 0 to 4 defective part in sample of 50 part. And I found I applied the binomial distribution, and I found the hiding to defective part in sample of 50 with a higher probability is 26.11%. The third I move to C, and C require to determine the probability random line chosen is space time to be greater than 180 seconds and shorter than 60 seconds. And I apply, and to find the probability, I apply the normal distribution model, and I calculate the calculation probability the dash time is greater than 180 seconds is 11.9%, and probability dash time is shorter than 60 seconds is 1.83%. Finally, I'm going to D. I'm going to recheck the new hypothesis, and I apply the DTF for the mean, and calculated the time is minus 866 is greater than the critical value is negative 2.015, and therefore I fail to recheck the new hypothesis. That is the end. Thank you for listening.